Okay, today's lesson is on 12.1, tangent lines to circles. So we're going to learn the relationship between a radius and a tangent line, and then use that relationship to find some missing values. So let me move it. There we go. Okay. So the first thing we're going to talk about is what is a tangent line to a circle. It is a line that intersects the circle in exactly one point. So this would be a tangent line. It just skims the edge of the circle, hits it in one point, and keeps going. Okay? That's different from, let's say, a secant line or a chord that intersects the circle in two spots. A tangent only hits it in one spot. The main theorem that we are going to learn about the tangent is that a line is tangent to a circle, so that if you can draw the radius out to that point where the tangent hits the circle, it has to form a 90-degree angle. That's the key piece there, is the tangent hits the radius at exactly 90 degrees at that point of tangency. That's what makes it a tangent line. So we're going to use that concept of the tangent line hitting the radius at 90 degrees to help us find some missing values. Okay, so our first example is this one, where this would be, if this line is a tangent line, this would make it a right triangle. So this angle would have to be 90 degrees. Let me get my pen here. Okay, so that would have to be 90 degrees there. So then what you would do is you would take, we know that the angles of a triangle are 180, so we would do 180 and we would subtract off the 90 and subtract off the 48 to get that value of x. So that would give us 42 degrees would be our angle for that one. Okay. We can do the same thing here. Notice I have two radius or radii drawn out, so that would make both of them, 90 degrees. Okay. But since this is a four-sided figure, we would not use, oh, how do I get rid of this? Okay. I don't know how to get rid of the pencil. Exit try. Here we go. Sorry. New tools. We would do 360 since it's a four-sided figure. We would do 360 minus the 90, and then minus the 107 that we know to get 73 for this one. Okay. One thing that you should note is that if you draw two radii, like this one and this one, these two would have the same length as well as those two having the same length. So that may help you in later pieces. Some vocab that we're going to talk about in this chapter are inscribed versus circumscribed. Inscribed means the figure is inside another one, hitting at tangent lines. Circumscribed is the figure that would be around the outside of the circle. So in this case, we would say the circle is inscribed in the triangle. We would say the triangle is circumscribed around the circle. Okay. And the what we're going to use that for is that when you draw tangent lines, the length for each one, oops, what did I do? Why won't it let me? Oh, here. The length from the tangent line to that point of tangency will be the same on both sides. So these two lengths would have to be exactly the same length. Same thing over here. This length would have to be the same as this length. And then thirdly, this one would have to be the same as this one. So what will that look like in a problem? Well, you're going to get a problem like this, where it'll say circle C is inscribed, so it's inside the polygon, and they want you to find the perimeter of that. Okay, I'm going to give you some of the values, but I'm not going to give you all of them. So you have to use what we just did in the last page, where we noticed that these distances are the same, to find our missing values. So this one would have to be the same as this one, so we know from Y to the circle would have to be 11. And we know that from Z here is 7, so Z here would have to be 7. We know that from X to the circle's 8, so from X to this part of the circle is 8. And since W to this part is 6, W to this part would also be 6. So we didn't know Y, Z, and XW. We knew 19 and 13, but we didn't know the other two. But now, because of that relationship, we do know. We do know that WX is going to be 14, and we know that YZ is going to be 18. So we would just add all those together for perimeter and get 64 feet would be the distance all the way around. Whoops. Okay. Another kind of relationship that we're going to learn because of that 90-degree angle that we were just talking about is that if you draw the radius in the tangent line, yes, that makes a 90-degree angle, but then let's say you draw this third line out here, that creates a right triangle, which opens up all of our chapter 8 stuff. Specifically, we're going to use Pythagorean theorem a lot in this chapter. Because we know that this is a radius, we would know this value, but we know that the whole thing is 10. So for this problem, we would set up the Pythagorean theorem, and we would say that x squared plus 6 squared equals 10 squared. Remember that 10 has to be the hypotenuse, so it has to be the C value. So then we would do 36, we would square our 6, square our 10, and then we would subtract those. 100 minus 36 would give us 64, and then don't forget the last step of the Pythagorean theorem is always to square root. To get rid of that squared, we have to square root. That's the opposite. So the square root of 64 would give us 8. So that's how we would solve a problem like that. We're going to also use that for this kind of, this is a more application-based problem. We say a belt. This would be like two pulleys with a belt going around. It says to find the distance between the centers of the pulleys. So they're looking for this, the length of this dashed black line right here. Okay. Here's the trick with this problem. Is as it sits, this is a quadrilateral. Now, because this is a tangent, we know that this is a 90-degree angle, and we know that this is a 90-degree angle. But still, that does not help us find lengths. So here's what we're going to do. We're going to use this line, and we're just going to slide it down. As long as we keep it parallel, then we can just drop it down. And specifically, if we drop it down the length of this smaller radius, it now becomes a triangle instead of a quadrilateral. This angle is still 90 degrees. Okay, so I'm still going to put, I can still put a little square there. So the lengths of our sides of our triangle, this one would obviously stay 15. The black dash line is still what we're trying to find, but now this side has changed because we've dropped that whole side down 3 units. So if you do 7 minus 3, this side of the triangle is now 4. So we would set up, notice where the right angle is, so the x would be our hypotenuse. So we would set up our problem, and we would say that 15 squared, that 15 squared plus 4 squared equals x squared. Okay, and then we would do the Pythagorean theorem again, because we know 2 sides of our triangle. We're trying to find the third side. We're trying to find the hypotenuse. So 15 squared is 225. 4 squared is 16. We would add those together and get 241. And again, our last step, remember to square root the 241. We would have to square root that to get to the 15.5. Okay, so that's how long that piece would be. But the key is knowing that you can slide that down, and as long as it stays parallel, that works. Okay. Just a heads up, on number 4 on your practice sheet, there is a bit of a challenge problem. So when you get to number 4 on your practice sheet, this is how it is set up. You're still going to do the Pythagorean theorem. You're going to do x squared plus 8 squared. But on this side, the hypotenuse is going to be x plus 2 squared. Okay? And then you're going to have to FOIL that. So you're going to have to do x plus 2 times x plus 2. So x squared plus 2x plus 2x plus 4. So that's how you're going to get here. You're going to have to FOIL here. Now, the nice part about this one, let me remind you here to FOIL. Yeah, that's supposed to say FOIL. Sorry. FOIL. I'm not quite sure how that happened. That didn't look so good. But you're going to have to, in number 4 on the practice sheet, that's what we're doing. Okay? So the nice part about this, however, is that once you get to this point, you have an x squared on each side of the equal sign, so your x squareds will cancel. So then you'll be down to 64, and you can just subtract your 4 and then divide by 4, and x would be 15. Okay? So that's just a heads up on the practice. That's it for this lesson.